So hello everyone, welcome to OneClass YouTube channel. My name is Devansh and today we'll go through a couple of popular algebra questions. So these questions are going to be at let's say middle school level or middle school to high school level. And yeah, obviously you can get these questions in aptitude exams. And so a little bit background of myself. So I am in the final year of my graduation and I am doing my graduation in aerospace engineering. So and if you need any tutoring help or if you need any one-to-one live sessions, then you can check the links in the description below. And I will just start with the lesson today. So, so here we have question number one. Um, so what is the recursive formula for a geometric sequence? Um, I will just a minute, just a minute. Okay, so yeah, um, recursive. Oh God. Recursive formula for a geometric sequence. Now, basically, first I'll tell you what is a geometric sequence. So let's say we have a number, let's say A. Then in series, what we do, we write another number for the second term, like A1 is the first term or the first term of the series. For A2, what we do, we just multiply with the previous term. We just multiply R with the previous term. Now here A is called the first term and obviously A2 is second, and R is called the it is called the common ratio. I think I just need to just clarify this. Um, just a minute. Here also they haven't given. I'm not sure. I cannot remember. Like in arithmetic series, it was common difference. Here it is common ratio, I guess. And similarly for let me write this A1. Okay. And similarly for A3 also, we write the previous term, which is A2 times R. So in the similar manner, we'll have a geometric sequence term or geometric series. Yeah, so I'm very sorry for that. So, yeah, so then we have the other terms which are so it will go up to an, and that will be an minus 1 times again r. Now the recursive formula states that we need to calculate the nth term. So basically, to calculate the nth term, we use recursive formula. Yeah, and I have already told you the recursive formula. This is the recursive formula. To calculate nth term, what we do, we write a n equal to a n minus 1 times r. We can also write this in terms of the first term multiplied with the common ratio. So the first term is a, and this will become, so for first it was r power 0, second it was r power 1, so then it will be n minus 1. So it is r power n minus 1. Yeah, so this is the recursive formula for a geometric series or geometric sequence. And I guess that that is pretty much all for this question also. In a geometric series, first term is a1, then they have the geometric series, here nth term, we multiply n minus 1th term by r, and then we get the recursive formula for geometric series. Yeah. So the solution given here is correct. Good work. Solution is correct. Just a minute, I guess I am having now it looks better. Okay, yeah. So for the second question, okay, um, I'll just add one page here, and I'll write with the red color now. So this is our question number 2. So here it is asking that what is the definition of a quadratic formula? So definition of a quadratic formula. So let's say we have a quadratic equation, and that equation will be, let's say, ax square plus bx plus c equal to 0. So this is a quadratic equation. So to calculate the roots of this equation, we have a direct formula, that is x equal to minus of b plus minus square root of b square minus 4ac over 2a. So this is the formula. So we'll get two roots here. One will be the case where this positive sign is considered, and the other one will be when a negative sign is considered. So let's just cross check this with a quadratic equation. So for example, I have an equation, let's say um, x square plus um, let's say x square plus 3x plus 2 equal to 0. Now in this case my a is 1 because coefficient is 1 here, and my b is 3 and c will be 2. Now I'll use this formula, so I can write like this. So minus b, that means minus 3 plus minus square root, then b square will be 3 square minus yep, so it will be b squared is 3 minus 4 into this is 1 and c will be 2. Yeah, over 2 times of 1, so x will be minus 3 plus minus under root of this will be 9 and this will be 4 to the 8 over 2. So this will become, this will be 1 and square root of 1, and yeah, square root of 1 is nothing but 1 itself, so I can write like this. So this will be x equal to minus 3 plus minus 1 over 2. Now I'll just write this as x1. So first we'll consider the plus sign. So this will become minus 3 plus 1 over 2, and that will be minus 2 over 2, negative 1. X2 will be, then we'll consider the negative sign. So this will be negative 3, negative 1, minus 2, negative 4, that will be negative 2. So x equal to minus 1 comma minus 2. These are the roots of the equation. I'll just solve this equation using the factorization method. So this is x squared plus x plus 2x plus 2 equal to 0. Then I can take x common, so this will be x plus 1 plus 2, x plus 1. This will be x plus 2 times x plus 1, and yeah, so this will be x minus 2 minus 1. Okay, so basically in this way we have also proved that the roots of this equation was negative 2 and negative 1, and in this way we can just calculate the roots of any quadratic equation. And I think that is also pretty much for this one also. And according to this, so basically here a minus sign is not printed, that is an error with this website. So I just hope that they'll rectify this error soon. So here whenever we'll see a blank, then it means that it is a minus sign. And yeah, good work. So we have the next question, which is question number 3. I'll just scroll this down, add a page. No. Yeah. So can you solve this? Okay. Question number 3. We need to fill the boxes, and I'll just write dash 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 equal to 30 degree. Sorry, 30. And this is the options are 1, 3, 5, 7, 9, 11, 13, 15. So the thing is that here we can clearly see we have 1, 3, 5, 7, 9, 11, 13, 15. So we can clearly see that all these numbers are odd numbers, and it is a kind of rule, or it is a kind of common sense that when we add any two odd numbers, then we'll always get an even number. but when we add three odd numbers, we'll never get an even number because two odds will make one even, even and odd again will make an odd. So, and we can clearly see that 30 is an even number, and all these numbers given here are odd numbers. So basically these kind of questions come in the aptitude exams of like GRE, or like recently it appeared one of in one of the exams. I'm not sure what kind of exam it was, but yeah, I got this question on WhatsApp also. Mm, हाँ. Hmm. Yep. So these kind of questions appeared in exams also. So one trick which I saw was pretty much interesting, that like first I'll tell you that there is no direct answer for this question, and there is no correct answer. By direct I mean correct only. So what kind of solution I heard was that um, here keep the value as this will be so 30 and 24. So keep, yeah, so do the addition of 11 plus 13. This will give us 24, and for the third digit what we'll do, we'll just invert this 9. So if we rotate this 9 180-degree, then it will become 6, and that will be an even number. So add 6 and we'll get 30. So this kind of solution I heard, and I was also pretty much amazed that we are just flipping the question to get the answer. But the thing is that again, like these questions do not have any direct answer, so therefore you need to manipulate the question to get at least some answer. And here also in the solution given here, I'll just read this. So in order to solve this, we have to analyze the given sum. Since the given sum 30 is an even number, it is impossible that all three addends will be odd whole numbers, because adding three odd numbers will result in an odd number only. So however, the given numbers that we are allowed to use are all odd numbers. Hence the trick for this is to create two decimal addends by putting the decimal point in between two numbers. So here they are basically, again they are manipulating the question, because here whole numbers are given and here they are converting it in the decimal form. So what they are doing is that again they are playing with 13 and 11. So they'll just write 13.3 plus 11.7. This will become 25. Yeah, so this will become 25. And so this number is done, this one is done, and we can use 5. So we'll get the sum as 30. So like again I'm saying that these kind of questions do not have any direct answer, and they do not have any correct answer. So we need to look for the options, and according to options we'll manipulate the question in so that we can get an answer. And obviously you can have an option which is none of the above, but that truly depends on you. Like I don't know whether you should write none of the above, or you should just manipulate the solution. Okay, so we have um, question number 4. So what is the quotient property of logarithms? Okay, I just read the statement given by the junior tutor first. So the quotient property of logarithms states that if the arguments of a logarithmic divided function divided, then you can rewrite the logarithmic function as two logarithmic functions of the same base, where one log function containing the argument in the denominator is subtracted from the log function containing the argument in the numerator. So basically, let's say we have a condition. Uh, Two numbers are inside the this log operator, and like a is divided by b. Then we can convert this in the form of log a minus log b. And yeah, so this property basically is an indirect application of the product property of log. So um, um, so basically what we can do, we can write a into b inverse, and then we'll use the what was the property was product property. So we can write log a plus log of b inverse. Then again we can use one property in which the power of this number comes out from the log and it is multiplied with this. So it becomes log a minus of log b, because this minus 1 comes out from the log and it is multiplied with the log itself. So this was a short kind of derivation, but it can also confuse you. So uh, instead, you can just go with this one only. And so we can also use the opposite of this. So basically, if we have the condition where we have the if we have any condition where let's say log of some number is subtracted from log of some another number, then we can combine it in one single log. So I can just write like this. Let's say log of um, 10 by 100 by 10. Let's say log of 100 by 10. Log of 100 over 10 will be, by using the property, I can write log of 100 minus log of 10. Now note one thing, that I am not writing the base of the log here, because I am taking the base of the log as 10. If it is something else, if it is natural log, then I'll be writing ln, or if it has some any other base compared to 10, then I would be writing that number itself. But here the base of log is 10, and I think log of 100 is 2, and log of I'll just use my calculator. So log of 100 was 2, yep, and log of 10 is, I think, 1 on itself, yep. So this will become, on the RHS we have log of 100 which is 2, log of 10 which is 1, so this will become 1. And here again I can just do the division itself, so it will become log of 10, and I know that log of 10 is 1, so 1 and 1, so LHS equal to RHS. And yeah, again we can, if we have been given with this statement, we can just use the property and we can convert it in a single log, and then we can do the division and we can obviously get the answer. So let's say one more example. For one more example, I have log of let's say x square minus 1 equal to, sorry, not equal to, minus log of x minus 1. So I can use this property, and this whole term is treated as a single term only here. So this will become log of x square minus 1 over x minus 1. Then what I can do, I can just split this term. So I'll use the property a square minus b square, which is a plus b times a minus b. So this 1 can be written as 1 square. This will become x minus 1 times x plus 1 and over x minus 1, and we can just cancel this, and the simplified form will be x plus 1. So I guess again for this question we have, like, we can go the definitions are endless, we can go anywhere. I'll just say that the solution given here was correct. So correct solution. Good work. This was question 4. This will be, I think, question number 5. Yeah, I'll just add one more page. Yep, so we have another question, that is question number 5. So we need to write a polynomial function in standard form with real coefficients whose zeros include 2, 7i and negative of 7i. So we need to write polynomial with real coefficient, and zeros are 2, 7i and negative of 7i. So if you don't know what I is nothing but I is square root of negative 1. So basically it belongs to the family of complex numbers, and to find the polynomial, if we have zeros, let's say I have a polynomial, I have let's say zeros of polynomial is a, b and c. Then to find to form the polynomial equation of that, I'll just write x minus a, x minus b and x minus c equal to 0. So here in this case we have been given with 2, 7i and negative of 7i. So I can write it as x minus 2, x minus 7i, x minus negative of 7i equal to 0. So this will become x minus 2, x minus 7i, and this will become x plus 7i. Now I'm going to use one property here. So it is a square minus b square equal to a plus b times a minus b. So I'll use this property for these two terms. So it will become x minus 2 x square minus 7i whole square, and this is equal to 0. Now the thing is that I have already told you what is I. So if I do the square of this, so it will become negative of 1, and therefore we'll multiply negative of 1 here. So, and the square of 7 is 49, and we again have I square, so I square is negative 1. So this 7i whole square will become negative of 49. Again, this I square is negative 1 and 7 square is positive 1. We'll just multiply both of them and we'll get negative of 49. So this is x minus 2 x square, and this negative and negative. Okay, I'll just write another step for that. And again I can just club this negatives, and this will become one positive. Now we'll be multiplying these two terms. So first I'll multiply both of these terms with x, then negative 2. So this will become x cubed, then plus 49x minus 2x square, and this will be 49 times 2, that will be 108, I think. 49 times 2, 98, yeah. So this was negative of 98 equal to 0. Okay, we'll just rearrange this from higher order terms to lower order terms. This will become x cube, then minus of 2x square, then plus 49x, and then negative of 98 equal to 0. So let's just check the solution given by Junior Tutor. X cube minus 2x square plus 49x minus 98. So yeah, we have got the correct solution here, and the procedure is also correct, I think. Yeah, the procedure is also correct. So I'll just write correct solution. Good work. Mm, So this was question 5, and this will be question 6. Yeah. So question 6, it is asking for what is the span of a matrix. So the span for the span. So I'll just first go with the definition given here. So a set of vectors spans a space if every other vector in the space can be written as a linear combination of the spanning set. But to get to the meaning of this, we need to look at the matrix as made of column vectors. So here's an example. Okay, so they have given a matrix M, that is 1, 2, 3, and 5. And so basically for span, what they have done, they have divided this matrix into column vectors. So basically, if you're not familiar with vectors in like engineering, or especially in case of MATLABs and computer programmings, we encounter with these terms like column vector, row vector. So um, in this case, um, we'll just divide this matrix into column vectors. So basically, what is a vector? A vector is a matrix of single column or single row. So it can have like n rows but one column, that will be column vector, or one row and n columns, that will be a row vector. So I can divide this matrix, so M was a matrix, then into two column vectors. So let's say first vector is, let's say M1, that will be 1 3. So again you can see that we have only one column but two rows, and then we have m2, that is 2 and 5. um, so this has column vectors 1 3 and 2 5 which are linearly independent, so the matrix is non-singular, that is invertible, and etc. Now let's see what they are doing. So let's say that we want to show that the generalized point x comma y is the span of these two vectors, that is, so the matrix spans all of R square. Then there are scalars a and b such that, so there is going to be a condition, that is, and this will be sorry, b times 2 5 equal to x y, and we can just multiply these scalar terms, so this will become a 3a, and this will become, sorry, b, we have to multiply b, so this will become 2b 5b, this will be x y, and this is a set of linear equations, so we can just separate them, so this will become a plus 2b equal to x, and this is 3a plus 5b equal to y. Now let's see what they are doing here. So they are solving this equation, okay. Mhm. So let's say they are solving this equation for a and b. So a will be, okay, so they have, okay, so they have solved this simultaneous equation, and what they have done here, if I multiply 3 this will become 6. Let me just do this. This will be 3a plus 6b equal to 3x, 3a plus 5b equal to y, minus minus minus, so this will become 6b equal to 3, sorry, 1b, or b, just b, is 3x minus y, and then we'll put the value of b here, so this will become a equal to x minus 2 6x minus 2y, this will be plus, and this will become minus 5x plus 2y, so it will become minus 5x plus 2y. Let me just cross check. Yeah, so we'll just solve these two equations to get for a and b, and now what we'll do, let's say a is -4. So basically to check the span for this matrix at 2 comma 3, so a is -4 and b is negative, sorry, b is 3. We just go for that simple case. So this will be 1 3 plus 3 times 2 5, and I'll just calculate this, so this will become -4 and 3, and this will become um, okay, for 2 and 3, okay. So basically we'll be keeping this 2 and 3 in these equations, this one and this one, and we'll just check this, that whether in the LHS we are getting 2 and 3 or not. So this will be 4, 3 2s are 6, so -4 6 This will be through 3, this will be minus 12, and this will be 15. So 15 minus 12 will be 3, yeah. And okay, so in the next step they have done the same thing only. So I guess that is all for this question also. I'll just write that the solution given here was correct. Like the span of the matrix, we generally don't do such kind of problems. We just do it directly. So correct solution. Good work. That one was, I guess, question 6. Yep. This is going to be question 7. We need to solve. Let me just cross check. Yep. Okay. So we need to solve for 2x minus 3 plus 7 equal to 3x plus 5. So basically we'll be solving this equation for x, and we'll find the value of x. So first I will subtract 7 from both these sides. So that will be minus 7 plus 4 times 2x minus 3 plus 7, 3x plus 5 minus 7. So this and this will get cancelled, and this will be negative 2. So it will become 4 times 2x minus 3 equal to 3x minus 2. And now I'll divide both these sides by 4, I guess. No, I'll not divide it. I'll just multiply this 4 in this. So this will become 8x minus 4 3s are 12 equal to 3x minus 2. Now I need to bring this 3 on this side and this 12 on the other side. So I'll subtract 3x from both the sides, and I'll add 12 on both the sides. So this and this will get cancelled. So it will become 8x minus 3x equal to, and 3x is cancelled, negative 2 plus 12. So this will become 5x, yeah, and this will become 10. Now I'll divide both the sides with 5, and this will become x equal to 10 over 5, which is nothing but 2. Hence our solution should be x equal to 2. So let me just check the solution given here. So 8x minus 12, okay, so in the first step only they just multiplied the 4x, then they subtracted 3x, the final is x equal to 2. Okay, so we can definitely check this whether this x, the solution we got, which is x equal to, is correct or not. So how we do that is, we'll keep the value of x equal to 2 back into our question. I don't have any page, right? So I'll just keep the value of x back into the question. So it was 2 times 2 minus 3 plus 7 should be equal to 3 times 2 plus 5. So this should be 2 2s of 4, and 4 minus 3 should be 1. Yep, 2 2s of 4, and 4 minus 3 1, and 1 4s of 4 plus 7, and this should be 6 plus 5. 4 plus 7 is 11 and 6 plus 5 is also 11, hence our solution x equal to 2 is correct. Yep. Like, so basically if you are in any kind of exam, then you can definitely check through this. Obviously it will take a minute or two, but yeah, you can definitely do that. Like, it is worth doing because you will be sure that whatever the solution you have got is the correct solution. And here also I'm sure that the solution given was correct. Good work. That was question 7, I guess. Yeah. So this will be question 8. Mm. So this is going to be our question number 8. Just a minute. I think yep. So it is asking that what is the domain of function y equal to 1 over x, and we need to find the domain of this function. So the thing is that whenever we have such kind of questions where we need to find the domain of any function, we just try to see that at what values of x from minus infinity to plus infinity the function is valid. And so I can clearly say that I'll just start with few random values. So let's say with minus infinity. So the thing is that if you don't know, 1 over infinity is 0. Like, it is not, like, it is 0. Like, you just remember this thing because we use this a lot in our examinations and in practical problems. So yeah, 1 over infinity is 0. So if I check this for x equal to minus infinity, then this will be 0, because 1 over minus infinity doesn't matter if it is minus or not. Like, it will be minus 0, and there is nothing like minus or plus 0. 0 is just 0 only. Then we can check for let's say negative 4. So y will be 1 over negative 4, and again, yeah, 1 over negative 4 is a real value. So x is like, for x equal to negative 4, this function is valid, so negative 4 is going to be in the domain. Now let's check for x equal to positive infinity. Again, y will be 0. For x equal to positive 4, again y will be 1 over 4, which is real. um, what we can do here, um, let's put 1 over x as 0, not 0, 1 over x as infinity or undefined, so that we'll get the values of x where the function is going to be undefined. So if I just divide, or if I just take this term here and this one here, or if I just multiply both the sides with infinity and divide both of them with multiply both of them with x, so I can get x equal to 1 over infinity, which is 0. That means that at x equal to 0, our denominator, um, yep, so at x equal to 0 we'll get a value, y will be undefined. So basically what we are doing is that we'll be checking the denominator, and we'll be equating this denominator in such a way, or we'll be solving for x, especially for the denominator, in such a way that we'll just keep that x equal to 0, and we'll just find. So suppose in the denominator we had x minus 1, then we would have kept x minus 1 as 0, and we'll be finding x which will be plus 1. So in this case, at x equal to plus 1, y will be undefined because the denominator becomes 0, and whenever the denominator becomes 0, the thing is that the function is going to be undefined, and that value that value of x for which the denominator is 0, that particular value is not going to be in the domain of the function. So here I can say that in the domain of function, mm, x is an element of minus infinity to 0, but 0 is not included, union 0 to positive infinity. Like if I had x equal to, let's say, 0.0001, then also my y is going to be real value or defined. But at the exact location where x is 0, y is going to be undefined. And the graph should look like this, I guess. Um, it should look like, I guess, like this. I just need to check that. So for y equal to negative infinity, y is 0. Negative 1 over 4 will be 0.25. That will be somewhere here. And for x equal to 0, y is not defined. So, and this is touching 0. I guess it should be something like for x equal to infinity, y is 0. So it should be something like this. Y is undefined, yep. It would be something like this. Like I guess this should be the graph of y equal to 1 over x. Obviously, if we had more values, then I would have calculated, but uh, it is not necessary for this question to calculate the or to find the graph of y equal to 1 over x, because we just need to find the domain. And yeah, so critically or basically the shortcut for this is that equate the denominator to 0, solve for x, and you'll get the values where x or where function does not exist. So that is also pretty much everything. So correct solution, oh sorry, good work, good work. Yep. So this ends our session, and if you like this session, then please do hit the like button and do subscribe to our channel also, and do hit the bell icon so that you will be always updated with our next live streams. And again, this was Devansh, senior tutor at OneClass, and definitely if you need any help, or if you need to submit your own questions, or if you want like one-to-one live session, then you can check the links in the description below. And I hope to see you soon in my next video. Till then,